This question from cell work number 6, question 2. We have to solve for x. We're going to solve by factoring. I think it's easier first, since these are all negative exponents, if you reverse the order. So the 100 would go first, then the negative 29, and then the 1. This becomes 100x to the positive fourth, positive second, and then that will be your constant term. So you reverse the order, 100x to the fourth, and then the negative 29, and then the 1. Then you factor. So you have to find two numbers that are going to multiply to be 100, and add to be negative 29. So in this case, it's going to be a 25 and a 4, x squared, in the front of your parentheses when you factor this. And multiply be positive 1, they have to either be negative 1 and negative 1, or positive 1, positive 1. And to get a negative in the middle, they're both going to have to be negative. So that's negative 25 and negative 4 gets you negative 29 for your middle term. So now we got to solve this. You get 25x squared equals 1. So divide by 25, you get x squared equals 1/25. And then square root both sides. And when you do that, it becomes plus or minus the square root. Square root of 1 is 1. Square root of 25 is 5. So it's plus or minus 1/5. On the other side, you do the same thing. You get 4x squared minus or equals 1. X squared equals 1/4. Square root comes plus or minus. Square root of 1 is 1. Square root of 4 is 2. Plus or minus 1/5. Plus or minus 1/2. A. Bell work 6, number 3. To find the location of the hole in the graph, you have to factor the numerator. So I'll factor that by doing bottoms up. So I'll multiply the 6 times 4 to get 24. You need two numbers that multiply by 24 and add to be 11. That would be 8 and 3. But since we're doing the bottoms up factoring trick, now since there's a 6 in the front, you divide by 6. And you have to reduce each of those fractions. So that's 4/3, and then you move the 3 up. So it's 3x plus 4. That'll be 1/2, so you're going to move the 2 up. 2x plus 1. And if you check it out, 3x times 2x is 6x squared. 4 times 1 is 4. 3 and 8 equals 11. So it works out. Over 2x plus 1. So the location of the hole happens because something in the numerator cancels with the denominator. So 2x plus 1 cancels, which creates a hole. So you set it equal to 0. So you get x equals negative 1/2. That's the x coordinate. So it's not C. To get the y coordinate, you plug in what we just got to the leftover, the remaining portion, the 3x plus 4. Plug in the negative 1/2. So that's negative 3/2 plus 4. If you had a common denominator, that'd be negative 3/2 plus 8/2, which is 5/2. So it's negative 1/2, comma 5/2, B. That's the location of the hole. Still from Bell work 6, let's take a look at number 4. Say complex fraction or compound fraction. We're going to simplify these fractions by clearing the denominator. So we need to know the common denominator. We have 10 over 1, 5 over y, y over 10, and 1 over 20. So between 1, y, 10, and 20, the common denominator will be 20y. You multiply every term by 20y. So there's only a 1 in the denominator, so nothing cancels here. So we have 10 times 20y is 200y. Here the y's will cancel. So we have 5 times 20, which is 100. In the denominator, we have 10 will cancel to make that a 2. So that's 2y times y is 2y squared. And then the 20s will cancel. So you just get plus y. And now that it's simplified, there's not as many fractions involved. Now we just factor. On top, we can take out 100. And we'll be left with y plus 1. In the denominator, we can take out a y. So we got 2y plus 1. And we'd be left with 2y plus 1. So 2y plus 1 will cancel with 2y plus 1. We're just left with 100 over y. Which of the following is equivalent to x squared plus y squared equals 9? That's shifted to the left 5 and up 3. So this is a circle with radius 3, coming from bell work number 10. If it's shifted left 5, that means we are adding 5 to the x value. And if it's up 3, that means you take the y, and we're shifting it up, so that would have to be minus 3. If it's grouped in parentheses, it's backwards. So left is actually positive and up is negative. They're always backwards. Left you would add to the x, up you would subtract from the y. Similarly, if it was right, you would subtract from the x. If it's down, you would add to the y because it's backwards. Up is negative, down is positive. And then for negative, or for the x's, right is negative, left is positive. So positive 5, negative 3, that's B. Still on bell work 10, let's take a look at question number 2. The hardest part about this is not using a calculator, but it actually does not matter because if you look at these numbers, they're all 15,360. So what really matters is it a positive or a negative? And what are the exponents on your variables? So if you were able to use a calculator for this, you would start with the 10, C, and then the second number of our combination that we would do in our calculator comes from the fourth term, but you always subtract 1. So if it's fourth term, we're actually doing a 3 here. So it's 10C3, and then that's some number times our 2 parentheses. First parenthesis gets the 2x, the second parenthesis gets the negative y, and then you need the exponents that belong to those. The 3, which was, remember, from 4 minus 1, the 3 is the exponent on the second piece. And then combined, these 2 exponents will always add to equal 10. So if that's a 3, this has to be 7 so that they add to equal 10. So we know that the number must work out to be 15,360. We just have to decide if it's positive or negative, and then pick the correct exponents. So right here, we can see that we're going to end up with a y to the third and an x to the seventh, so either A or B. And then it's negative to the third power, which will be a negative answer. Negative to the third will be negative answer, so it's got to be B. And number 3 on the same bell work, number 10. Classify the following. So we're looking at x squared and y squared. Since they're both there, there's an x squared and a y squared. It will either be a circle, an ellipse, or a hyperbola. Parabolas are missing one of the squares. So it's not a parabola because we both x squared and y squared. Hyperbolas, one of them is negative, so here they're both positive, so it's not a hyperbola. Circles have the same coefficient, so it's not a circle. Ellipses have different coefficients, so that would be an ellipse.